Let's take a look at graphs and graphing utilities. And first one we're going to graph is the y is equal to x. There it is. Actually, I guess I better bring up my tablet too, because I'll need that here shortly. Okay. So I'm going to bring up my calculator, and I'll press y equals, which is right there. I'll press clear to clear out wherever's not line. You may or may not have something there. And then I'll press my X key, and then I'll push my graph button. And that should be the graph you get. Now I'm going to show you how to, if you got an error, I'm going to show you how to fix most of the errors. And then we'll also talk about the new style of calculator there are. So this is fixing graph mode on TI-8384. Now if you got that, then you don't have to do these steps. But at some point you probably will screw up your calculator, so if you just want to do these just to get comfortable with them, then that's good. Our first one is we want to unhighlight plot 1, plot 2, and plot 3. Let's go see what I mean by that. Over here in your calculator, if I press y equals, you can freely go back and forth between y equals and graph. You see across the top it says plot 1, plot 2, and plot 3. If I up arrow, put my flashing cursor on plot 1 and push enter on it. And then I down arrow. So you see how plot 1's highlighted now? If I push graph, you'll have different things happen. One of them you could get is it could give you an error saying invalid dim. Sometimes it'll work. Other times it'll put like extra junk on your screen. That's a statistics graph mode. So by highlighting that, you'll get weird results. So that's one thing to fix, is to unhighlight those. So I'm going to press enter on quit here. I'm going to go back to y equals, and you up arrow, put your flashing cursor on whichever one's highlighted, so you may have to use your right arrow key. And once you got your cursor on it, you press enter one time. And now if I do a down arrow, see how it's no longer highlighted. So you want to unhighlight plot 1, plot 2, and plot 3. Our second one is we want to clear out y1 through y0. Yeah, let's see what I mean by that. Over here in my calculator, see I have this on y1. If I down arrow, you see it goes down to y7, and then if I keep going, there's y8, y9, and y0. Occasionally, somebody will get some garbage down here on y0 or y9, and I'll just put some random garbage like that. And then if they push graph, starts graphing, looks everything's good, and boom, they get an error. Now, unfortunately, this is kind of a little flaw with the calculator, I think. You see how quit is highlighted? People's natural tendency is to press enter. You know, when you're installing a software package, I did some of that today. I rebuilt one of my computers. You don't read the user agreement, do you? You know, it might be saying anything. It might be saying you agree to give your firstborn child away, or agree to call your firstborn child Bill Gates. You just click next, 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 so you can get it done. Well, the logical thing for people to do here is just press enter on the quit. And then they go back to the y equals, and they're looking. It's like, I do not see anything wrong. So they do graph again. Gives them the error again. What you always want to do is you want to choose the go to. So you want a down arrow to go to, and press enter. That'll actually go to where your problem is. So that is so beneficial. And once you go there, you see, oh, I got a lot of garbage. So if you just press clear on it, it'll clear out that line. So if you're having difficulties, go down through here and see if there's any garbage on any of those lines, and press clear on them. Now the third thing is press zoom and choose Z standard. So over here in the calculator, I'll press zoom, and you see the sixth one, Z standard. Now you can down arrow to it, highlight it, and press enter, or you can just press the number that's in front of it. So if I press 6, it'll do the down arrow and enter for me. Now I wasn't zoomed out at all, but again, that will fix a lot of problems, especially later on when you start doing a little bit of zooming. You have to do that to set it back. This has nothing to do with fixing errors, but the new TI-84s have a slightly different operating system on them, and I do want to mention it. If I go to y equals, and see I got x there. If I do a caret 3, this is what most people in the class will see. This is the old style, where it puts the caret like that. With the new calculator, if I press mode and I down arrow, you see up here where it says math print and classic. If I press enter on math print and highlight it, then do a second mode to exit out. To exit out of anything in your calculator, you do second mode. Now if I go back to y equals, I do x, I do a caret. Notice it no longer puts the caret there, it puts it into exponent mode. And now if I push 3, it'll actually look like an exponent. Now if you like this mode, that's fine, but whatever you're in, after you've typed in your number, if you just press a right arrow, it'll get you out of exponent mode, like that. But if you want your calculator to look like what the video is going to look like, what you see in class, at least my class, go to mode, down arrow to the second page, and on the line that says math print and classic, right arrow to classic, so highlight it, and press enter on it to select it, and then do a second mode to exit out. Now if you've gone to mode and you don't see that, that means you got one of the older style TI-84s or TI-83, so you don't need to worry about those steps. But anyway, let's look at the next one. Now these are all the basic building blocks on the TI-83, TI-84 calculator. Everything you'll do in intermediate and college centers around these particular functions. So here we got y is equal to x squared. Well, I'm going to press y equals. I'll press clear to clear wherever's in that line. I'll press my x key, and then I'll push the x squared button. And then I'll push graph. And there's y is equal to x squared. Now in this one, I don't really care what y is equal to x to the third looks like. I'm showing how do you put any exponent in there. If you got third power, fourth power, 201st power, how do you put it in there? So let's take a look at that. I'm going to press y equals, press clear. I'll do an x key, and how you do any exponent on your calculator, besides the x squared, which has its own button, is you do it with a caret, and that's what's the exponent. Then I do 3, and then I push graph. And there's our y is equal to x to the third. Now let's look at this one right here. Y is equal to x to the 1/2. And again, on this one, I'm not demonstrating how to graph y is equal to x to the 1/2. Could care less about it. I'm showing how do you put it in when you got a fractional power. Now this is specifically when you got more than a single x or single number up in your exponent. How do you put it in? The key to it is we have to put parentheses around the exponent. Now if you're on one of the newer TI-84s and you leave it in exponent mode, that math print or whatever it's called, you do not have to put those parentheses. So let's put this in there. There it is. So press Y equals, press clear. I'll press my X key, caret, beginning parentheses, 1 divided by 2, closing parentheses, and then graph. Oops. There, graph. And that's our answer. And again, I'm not demonstrating how to do y is equal to x to the 1/2, but how to do any fraction. Let's take a look at the square root of x. Well, I'm going to press my y equals, press clear. Now, you'll notice above the x squared is the square root symbol. So to get to that, we press second button one time, and then the x squared. And it'll put the square root with a beginning parentheses. Put my x in, and then I'll put a closing parentheses. The newer TI-84, if you leave it in math print, it'll put the square root, and you put your x in, and you have to do your right arrow key to get out of it. And then graph. And that's our answer. Now that was the same as x to the 1/2, which they should be because they are the same. Now square root you run across pretty often. The next one is a cube root, and you run it across it fairly often also. So let's look at it. So press y equals, press clear. Now if you can't find your math function on a button or above a button, it's probably underneath the math button. So I'll press math. And you see the fourth one here is the cube root. And you can either down arrow to it and press enter on it, or you can press the number that's in front of it. I'll go ahead and press the number that's in front of it. It does the down arrow and enter for you. So I'll do 4. And it puts the cube root and puts x in, and then my closing parentheses. And then I'll press graph. And there's my cube root of x. Well, what happens if you have a 4th root in there, a 5th root, 17th, 300 or 353? So you can have any number in there. Well, we can't have a function for each one of those. So this here, we're not demonstrating how to do the 4th root of x. We're demonstrating how to do it when you have any number in that slot. Now that slot is called your index, the number that's in there. So let's go see how to do this. I'll press y equals, press clear. You put your index in first. So I'm going to go ahead and put the 4 in first. Then I'll go to math. And I want to choose the one with a radical with an x on it for the index. And that's number 5. So I'm pressing number 5. Now this is the only function that doesn't put a beginning parentheses. So you have to put the beginning parentheses on it. And it's x. And then closing parentheses. Now on this particular one, if you just put the x, it would work. But if you had anything more bizarre than just a single x or single number in there, then you have to have the parentheses there. It's a flaw with Texas Instruments, what they did with it, because one of the earlier versions of the Texas Instruments didn't have any of the beginning parentheses. And then they got feedback saying, hey, we're tired of typing in the parentheses. Could it just be there by default? And they put it on every function except for this one. Anyway, I'll push graph. Get off my little story. And there's my y is equal to the 4th root of x. Let's take a look at the absolute value of x. So I'll press my y equals. I'll press clear. The absolute value of x, it's not on a button, it's not above a button, so you probably guessed it, it's underneath the math. This one's hidden a little bit though. We have to right arrow to the num menu. Once we do that, you see how the first function is ABS, and it's already highlighted. So we just push enter on it. It put the beginning parentheses there for us, so we'll put the x in, put a closing parentheses, and graph. And that's our absolute value of x. Now this next one, we're not showing how to. I could care less what this graph looks like. Y is equal to x plus 2. Let me actually sketch it over here. What is this? 9. Y is equal to x plus 2. You'll see more of this later on in the course. Whole section on this. I could care less what this graph looks like. What I'm demonstrating is how do you graph a fraction. I have to quit watching this silly show. Dawn of the Dead's on. Second time I'm watching it. How do you graph it when you got a fraction? And specifically, you have more than a single x or single number in your numerator or denominator, top to bottom. Well, if you have more than a single x or single number, you have to put parentheses around top and or bottom. So put parentheses around the x plus 2 and parentheses around the x minus 3. And we'll graph it exactly as you see it. So let me come over to my calculator, wherever it's at. There it is. Okay. I'll press y equals. Press clear. I'll do a beginning parentheses x plus 2, closing parentheses divided by beginning parentheses x minus 3, closing parentheses, and then graph. Now this is what our graph looks like. If you're on a T83, it'll put an extra vertical line there. Those vertical lines that you may see at various places are never part of your graph. It's a flaw with the calculator. I was actually curious, so I went out to Texas Instruments website and read about it, and I thought they were putting a vertical asymptote on there. I thought, well, that's nice of them. And I got to reading their description of that. It's a flaw. They didn't mean to put it on there, which is why they fixed it here. Let's look at this one. Let me write this one down. Y is equal to negative square root of negative x minus 3. There's confusion on the calculator. You got a little dash down here at the very bottom row, and you got a dash right here. Well, this is the minus, and this is the negative. And people will interchange those, use them in the wrong place. Now, sometimes you do that, you'll get a syntax error. We love syntax errors. Because syntax error, all you have to do is choose the go-to, and it'll take you directly where your problem is. And if it puts a cursor on a dash, you know you picked the wrong dash. Occasionally, you'll use the wrong dash, and it just gives you the wrong graph. Now, that's what we really hate. Because maybe you've done that on a test and you feel good about it because you plugged in a calculator and you miss every point just because you chose the wrong little dash. So this is going to help you with that, hopefully. If your little dash is at the very beginning of whatever, then it's a negative. So this one here at the very beginning here is a negative because it's the very beginning of my problem. Now this little dash here is at the very beginning of my square root, so it's a negative. Now if your dash is between two things, see how this dash here is between the x and the 3? Then that'll be a minus. So we're going to pretty well type that in as you see it, using those as our guidelines. So press y equals, press clear, put the negative in first. Square root, remember the square root was second x squared. Then I had another negative, and then x minus 3, and then I'll put a closing parentheses. And then I'll push graph. And that would give us our answer there. Let me go back to y equals. I think I know which one to change such that it just gives us the wrong graph, doesn't give us an error. Let me come here and put a negative. And then I'll push graph. Look at how that changed that. It flipped it over from this side over to this side. It's a completely wrong graph just because you put the wrong dash. This is why I say we like errors. Errors are nice because then we can go fix it. But if we don't even know there's a problem, then we can't. Let me change this back to a minus. Okay, and let me make one of these a minus. Like this first one, that should be a negative. Let me make that a minus. And now let me push graph. Boom, syntax error. Again, we love that because we just have to down arrow to the go-to or press number 2 and enter on it. And it takes it and puts our cursor right where the problem was. And you can see, oh, well, that's a wrong dash, I guess. Must be the other one. So you can put a negative and then graph it and you get the right answer. People look at me kind of funny when I say we like errors, but it is beneficial on some of these. Okay, now let's take a look at a problem. And this is typically a type I put on the first test. I put something on there such that you have to use your graphing calculator for. I do not want you to plot points. Know why? Maybe you're the best point plotter there was in elementary algebra and intermediate algebra. Let me graph something here. Maybe everybody else was happy with 2 or 3 points. You kept going until you had like 7 or 8 or something like that. Well, look at all these points here. You did a T-chart. You came up with all these points. Well, what is this graph? Well, it looks like that U-shaped graph, right? Parabola. But it could be that this graph, not that I can actually draw something to those points, but there could be the graph is a heart. You just didn't plot enough points. Could be graph is coming up like that and coming back down. You just didn't plot enough points. Maybe you had to plot 50 points to see this. So plotting points is a horrible, horrible method. It works when you got very simple graphs, but when you get anything complex, it doesn't work at all. Now in college algebra, we learn one technique to help us get a better picture of the graph. But really, it's not until you get to calculus of some sort, whether that's business calc or calc 1, where there's a whole chapter that how do we find a true graph? The mins, maxes, concavity, and all that. So anyway, I digress. This is one that you probably wouldn't want to do by plotting points. So let's just go ahead and graph this and see what happens. So press Y equals, press clear. We got x to a power, and specifically the power has more than a single x single number in it, so we're going to need parentheses around that power. So let's do x caret, then I'll put a beginning parentheses, and then we got x squared, so I'll do x key and then the x squared button, minus 3x, so minus 3x, and then plus square root of x. So plus, remember the square root is second x squared, and then I'll do the x key. I'll put a closing parentheses on the square root, closing parentheses on the exponent. T83, T84, you don't have to put those closing parentheses at the very end, but they don't hurt anything either. Now push graph. And that would be our particular graph. Well, the next thing involves intercepts. So let's talk a little bit about that. We got our X Intercepts. And this is where it crosses the x-axis. And then we get the y-intercept. Usually there's just one in college algebra, but I'll put an S on there just in case. And that's where it crosses the y-axis. Now specifically, we're going to be looking at graphs, and we're looking where a graph crosses the x-axis. So let's look at number 12 here. It says determine the x-intercepts if any. Well, this crosses at 2. Looks like on my x-axis. So this will be 2. If you want to write it in point form, it'd be 2, 0. Part B says determine the y-intercept. Well, it looks like negative 4. So it crosses at negative 4. And if you want to put it in point form, it'd be 0, negative 4. You'll find that books will go back and forth between these. Sometimes they'll have in point form, and then later on they'll drop that and they'll just have the numbers here. Let's look at another one. Part A, determine the x-intercepts if any. Looks like it crosses at 2 and 3. So we got 2 and 3. You could write it that way, or if you want to write it in point form, it'd be 2, 0 and 3, 0. Now part B says determine the y-intercept, which looks like 6. So So you could write it as 6, or if you want to write it in point form, it would be 0.6. Okay. Now some items on your calculator. We're in graph mode now. To get back to your calculation mode, you just do second mode, and now you're ready to just do your normal, 9 times 2 or whatever you're doing. Second mode gets you out of anything. And that's actually the end of that section.